everyone. This is Saritha, working as Assistant Professor in the Department of ECE, Institute of Aeronautical Engineering. Today's session I am going to explain about definitions on Module 1. So, in Module 1 is nothing but Digital Image Fundamentals. So, in this module, what are the topics we are having here? Digital image through scanner. So, how we can capture the image and with the use of camera. So, how to scan the image and digital camera, concept of gray levels and gray level to binary conversion, sampling and quantization, relationship between pixels and imaging geometry. So, in this module, the basic topics are first one, how to capture the image. So, what is the first step in our digital image processing? Here it is image capturing, image acquisition. So, for that case, we are using digital camera. In that digital camera works on the basic principle of charge coupled device, and we are using in the charge coupled device, we are using number of sensors arranged in a array form. So whatever the light energy falls on that sensor, it gives the proportional output voltage. So with the use of sensor, it converts the electrical light energy into electrical form. So next one is concept of gray level. So what is mean by gray level here? Already I explained the concept of gray levels. Gray level is nothing but it is also called as intensity. Intensity is nothing but here the digital image is represented in the form of pixels only. The combinations of rows and columns from pixel is formed. Here the formation of rows and columns, this one is 1 pixel and here it is also 1 pixel. The image in digital image processing, image is represented in the form of digital, means here we need to consider pixels. So here each pixel has its own gray level value. So here the gray level values are we are representing with 0 to L minus 1. So L is the L minus 1. Here we are representing the gray level here with L. 0 to L minus 1. 0 is the minimum gray level value. So L minus 1 is the maximum gray level value. Here L equals to 2 power k. L equals to 2 power k. K is nothing but k is number of bits we are using in each pixel. So number of bits we are using in each pixel. For example, in this we are using k equals to 8 bits. So L equal to 2 power 8. So we have 256. So the gray level value we are representing here 0 to 256 minus 1. Here 0 to 255. 0 to 255. The gray level ranges from 0 to 255. 0 is the minimum gray level and 255 is the maximum gray level. Maximum gray level. Here in this, and next one is gray level to binary image conversion. So how to convert the gray level means in that image it consisting of number of shades. So if we are using 8 bits in each and every pixel, here shades are 255 shades. So how to convert a binary gray level image into binary form means here in binary image we are representing only two cases, is either 0 or 1. 0 is the minimum gray level value, 1 is the maximum gray level value. So that is the binary image representation. And gray level, in this number of bits we are using in each pixel, depending on that we are having the gray level values. So if we are using 4 bits in each pixel, so in this we are having 2 2s are 4, 8 and 16 gray levels. So here number of shades are 16. So like that number of bits we are using in each pixel, based on that we are representing the gray level. And how to convert the gray level to binary image means in that in binary image only two, what is the minimum gray level and what is the maximum gray level. That maximum gray level we need to represent with 1 and the minimum gray level we are representing with 0. And next is sampling and quantization. So what is the importance of sampling and quantization in our digital image processing means sampling is nothing but it converts the continuous signal. So whenever the light falls on the sensor, so when we are going to capture the image for acquisition process, the first step is we need to capture the image. So we need image. Without image, we can't do anything in our digital image processing. So first, in acquisition, the first step is we need to consider the image. So for that case, we are using sensor. So with the use of sensor, whatever the light energy falls on this sensor, it gives proportional output. That output voltage, it is in the form of continuous only. Continuous means amplitude and time period both are in continuous form. So when we are applying the sampling, technique, it converts continuous signal into discrete levels, discrete amplitude levels. So after discrete amplitude levels, we are using quantization. With the use of quantization, it converts the discrete samples into fixed number of voltages. And here relationship fixed number of voltage level. This is the basic tech. This is with the use of this sampling and quantization, we can convert the analog image into digital form. So after quantization, we are using encoder. With the use of this encoder, it converts in the binary form. So relationship between pixels. And next one is relationship between pixels. In that, what is the important of pixel? So when we are going to represent an image in the digital form, here we are considering pixels only. Here pixel is picture element, PEL. Pixel is also called as PEL. It is a picture element. In that, pixels is nothing but if we are considering one image, that image size is 3 by 3. So 3 by 3 means we are having 3 rows and 3 columns. Total we are having 9 pixels. In this 9 pixels, what is the relation between these 9 pixels means we need to consider 4 adjacency, 8 adjacency and diagonal form. So when in this is 3 by 3 matrix. In this 3 by 3, this is my center point f of x comma y. Here 2 vertical and 2 horizontal neighbors are there. So this is the n4 of p. So in diagonal form also it consisting of 4 neighbors, that is represented with nd of p. What about n8 of p? Here it is n4 of p union with nd of p. So this is the relationship between pixels. In this relation, 4 adjacency, 8 adjacency, and how to find the path and how to find the connectivity path boundaries of an image. Here, that is the relationship between pixels and imaging geometry. So in this imaging geometry, how to works 2D image and 3D image. What is the coordinate system? So how to capture the image if we are connecting one camera in the with the use of this coordinate system, how to capture the image. These are the topics involved in our module 1 digital image fundamentals. So based on these topics, what are the definitions are there? We'll see. So here, first one, define pixel. So pixel is nothing but picture element. It is a smallest element of an image. So it is smallest element of an image. So consider here, for example, this is in this my image is there. Here this part is, this is my entire image. It covers total 9 pixels. 9 pixels. So this is 1 pixel. Here it is pixel 1. This one pixel 2. So it is smallest element of an image. Pixel is the smallest element of an image. So this is f of x comma y. Here this is f of x comma y. So we are having 4 neighbors. So here 2 vertical and 2 horizontal neighbors. So it is the pixel is the smallest element of an image. And define picture element. So pixel is also called as a picture element. Picture element is the smallest discrete component of an image. What is an image? So image is an array matrix. Here number of rows and columns, array of rows and columns is a square of matrix of square pixels arranged in a columns and rows. An image is an array or a matrix of square pixels arranged in a columns and rows. So here rows and columns arranged in a matrix form. Here it is depending on number of rows and number of columns. Here for example 16 row, 8 rows and 8 columns, 8 rows and 8 columns. So how many number of pixels are there in that the size of matrix? Here we are having total 64 pixels. Total 64 pixels. So 8 rows and 8 columns means total we are having 64 pixels. What is image processing? Here image processing nothing but one image is there. So for example, consider this image. We are applying some mathematical operation on that particular image. So when we go for transformation or enhancement, if you go for segmentation or compression, we are applying any one of the processing on that particular image is nothing but any one mathematical or transformation function or enhancement or filters. We are applying any one operation on that particular image is nothing but image processing. So here image processing is a method to perform some operations on an image. And region. So what is mean by region? So region is nothing but if we are considering an image, in that image if we are using 8 rows and 8 columns, total 8 rows into 8 columns means the image size in that we are having total 64 pixels. Out of 64 pixels, some pixels and some gray levels are 20, some pixels with the gray level of 60, some pixels are gray level or 30. So region is nothing but whose gray levels are same. Whose gray levels are same, join adjacent pixels also, that is the region of an image. So here a region in an image is a group of connected pixels with similar properties. So similar properties means here in similar properties here we are considering only gray levels. So depending on our requirement, here group of connected pixels. So group of connected pixels means adjacent pixels. So that adjacency either n4 of p or nd of p or n8 of p. n8 of p is nothing but n4 of p union with nd of p. And image acquisition. So for this image acquisition we are using sensor. So in this sensor, this is the filter, the light energy falls, this is light energy falls on the sensor, and whatever the energy falls on the sensor, it gives the proportional output voltage. It is output voltage. This is single sensor. So for this acquisition we are using sensor strip. Here number of different types of sensors are there. Here it is single sensor. We are having line of sensors and array of sensors. So depending on our requirement, we are using either single sensor or line of sensors and array sensors. But in our cameras, digital cameras, we are using array of sensors because of the camera works on the principle of CCD only, means number of sensors arranged in an array, each and every grid consisting of one sensor. So here maximum light energy falls on that particular sensor, it gives the maximum output voltage. So here in this acquisition, image acquisition is the creation of digitally encoded representation of the visual characteristics of an object. Visual characteristics and object. So how we will get this visual characteristics of an object means with the use of sensor only. With the use of sensor. So define dynamic range. Here the range of values spanned by the grayscale. Spanned by the grayscale is called the dynamic range of an image. Here consider one image. Image in this gray level. So for example, the grayscale, this is some white means maximum gray level. This is dark, completely black color. For example, this is black color. So here the gray level value is 0. Next some gray, little bit. So next it is white. So it is the dynamic range of grayscale representation. And define 2D and 3D images. So what is 2D image? So with the use of 2D image, it gives a height and width of an image. Height and width of an image. So when we go for 3D images, it gives an height, width and depth of an image. Here 2D defines two axes, x and y axis. So here 2D image is x and y axis. X and y axis, it gives height and width of the image. Height and width of the image. But when we go for 3D image, it gives height and width and depth of an image. So in this we are having three coordinate system, x, y and z coordinate system. X, y, here x, y, z coordinate system. So here it is 3D images. It gives height, width and depth of an image. But when we go for 2D image, it is x, it has only two axes, x and y. It gives height and width of the image. Height and width of the image. So 2D is defined as having two axes to plot, usually the x-axis and y-axis. 3D indicates three aspects which are plotted on the x, y and z directions. And define high contrast. So what is meant by contrast? Contrast is nothing but if you are considering an image, in that which pixel value is maximum. Which pixel value is maximum gray level, then it has more bright compared to other gray, adjacent gray levels. So here, when an image is appreciable, number of pixels exhibit high dynamic range. So the image will have high contrast. So high contrast means here that image is more bright. So compared to other images whose pixel values are, number of pixels are having maximum gray level value and the image is very clear, then contrast level also high, and at that time high contrast means it covers entire gray level value. It covers the gray level value. High contrast means the grayscale histogram representation. The histogram representation for high contrast of an image, it covers the scale. So entire scale. This is for high contrast of an image. And define grid. So grid is nothing but when we go for in sampling points or orders in the plane and the relation is called a grid. So here if we are considering a continuous signal can be converted into samples. Continuous signal can be converted into samples. So the sample points we are representing in the form of order only. So here plane and the relation is called a grid. Define contrast. So contrast is nothing but it is a def- defined as the difference in intensity between high and lowest intensity levels in an image. High and highest and lowest intensity levels or in an image. So if any image or anything, so some if you are considering any image, all pixels are not in the same level. So some pixels are more bright, some pixels are some dark, some pixels are white color. White means maximum gray level, gray means some medium gray level, and dark means it is low gray level. So contrast is nothing but it is defined as the different intensity between the highest and lowest intensity levels in an image. What is mean by gray level? So gray level is nothing but it refers to a scale or measure the intensity that ranges from black to white. Here the gray scale. So gray scale is 0 to L minus 1, 0 to L minus 1. So up to here the grayscale is here 25, 64, 128. So some here L minus 1. So minimum gray level to maximum gray level value. Here it is nothing but scalar. So here we are representing the grayscale in the form of scale only. 0 to L minus 1 means minimum to maximum grayscale. Define sensor strip. So here sensor for image acquisition or sensor strips are commonly used for inline arrangement in imaging geometry. So sensor strip means in we are having different types of sensors and scanners are there. So sensor strip means it rotates some angle, it rotates with some angle. Based on that rotation, capture the image. So in that we are having different types of sensors are there. So based on that sensor strip means sometimes it rotates continuously and it captures the image. Next, what do you mean by color model? So what are the basic colors? Red, RGB colors. So in RGB colors, so color model means a color model is a specification of a 3D coordinate system. So in 3D coordinate system, we are having x, y and z axis. X and y, z. Three axes are there in 3D coordinate system and subspace within the system where each color is represented by a single point. So in color representation, we need to consider number of colors and each color we are representing in a each color has its own level. So we are representing in a each point. Filter. So what is mean by filter? With the use of filter we can remove the noise components. So filter is nothing but in this we are having different types of filters are there. Low pass filter, high pass filter, band pass and band reject filter. So in that based on our requirement I need only low frequencies, so we are assigning the cutoff frequency whatever we required, we are assigning particular point only. For that case we are using low pass filter. When we go for high pass filter, I need a high frequency. Depending on our requirement we are using high pass filter, low pass filter and band pass filter. So in our image processing, if we are using low pass filter, it gives the smoothening of an image, and when we go for high pass filter, it is sharpening of an edges. So these filters is basically used in our image enhancement. In image enhancement, we are using median filter, average filter, maximum filter, and minimum filter. So in these all are order statistic filters. So with the use of median filter, we can remove the noise and we can remove the noise in salt and pepper noises. With the use of maximum filter, find out the brightest point in our image, and with the use of minimum filter, found the darkest point in our image, and with the use of average filter and Gaussian filter gives the smoothening of an image. Next, scanner. So scanner is nothing but whatever scanner is a device that optically scans image, that optically scans. Here scanner is also, in this also it converts the light energy. Light, if you are placing one paper, some printed paper, we are scanning that paper, means that light rotates from vertically and horizontally, it scans the entire paper. Afterwards it gives the electrical output, so it gives the output. The whatever we connected, the scanner output, we are connecting either printer or a cpu monitors, then it will appears. Monitor means display and printer means we will take printouts. So with the use of scanner also, it converts light energy into electrical form. This scanner is a device that optically scans images, printed text, handwriting, or an object and converts into a digital image. Digital image. In these scanners, we are having different types of scanners are there. Flatbed scanner, drum scanner, handheld scanner. So when we go for in shopping malls in somewhere, with handheld scanners are there to scan the barcodes. In shopping malls, each and every item is barcode is there, we are scanning. That is nothing but with the use of handheld scanner. And flatbed scanner in office purpose and any project work. So for that purpose we are using handheld scanner, flatbed scanner and drum scanner. So depending on different types of scanners are there, but only the operation is each and every scanner, the output is same, but depending on our application we are using different types of scanners. So the whatever the light energy falls on that paper wall, whatever we need to scan, so either paper or anything, we can focus pointing on scanner, focus on that object, then light energy falls on that particular object and it reflected back and it gives the electrical output. What is digitization process? So what is mean by digitization process means how to convert the analog image into digital form, means with the use of sampling and quantization, that a continuous image can be represented into digital form. In digital form, when we are going to present a image, we are digital images we are representing in the form of pixels only, m rows, and the size of the image we are representing with m into n. So here m into n, m rows and n columns. So here m into n rows, depending on m into n size, we are having number of pixels, and each pixel we have has its gray level value. So here the digitization process, that is the digital image has m rows and n columns, requires decision about values for mn and for the number. So L is the gray levels allowed for each pixel. So define analog image with examples. So here analog image is nothing but continuous variation. Analog image is nothing but continuous variation. Here it is x-axis, here it is y-axis. Here the input is continuously varies with respect to the time period. It is in continuous in form. So the example for analog images are television image, photographs, print, paintings and medical images. And define pixel value 0 and 255. So in 0, 255, here 0 to L minus 1. So in image, if we are using L equals to 2 power k, k is number of bits we are using, each pixel, and L minus 1 is the maximum gray level value. L minus 1 is the maximum gray level value. 0 is the minimum, means here it is 0 minimum. Here it is minimum gray level value. Minimum gray level means here it is dark. L minus 1 is the maximum gray level value. It is bright. So here if we are using L equals to 2 power k, number of bits we are using in each pixel, based on that we can decide the grayscale value. 0 to 255 means here 255 means k equals to 8, 2 power 8. Here it is 256. L minus 1 is 256 minus 1. Here it is 255 means 0 to 255. 0 to 255. So here minimum gray level in 0 and 255 means each pixel we are using 8 bits. Then here it 8 bits means L equals to 2 power k. 2 power 8 means 256. So 0 to L minus 1, 256 minus 1. Here it is 255. Here pixel value 0 taken to be black and 255 is taken to be white. Next, define interpretation. So the interpretation is called a assigning to recognize object. So sensor is nothing but it is a conversion sensor. It converts the light energy into electrical form, and with the use of sensor we can detect the object. A sensor, what here whatever the energy falls on the sensor means, here in this we are using different types of sensors are there. IR sensor, temperature sensor. So here we need to, so here sensors we are using a sensor is a device that detects and responds to some type of input from a physical environment. And next one is define gray level resolution. So here gray level resolution means here resolution is nothing but if we are using more number of bits each and every pixel, the image quality is good. If we are reducing the usage of number of bits in each and every pixel, the picture quality is also reduced. So resolution is maximum means that picture quality is good. So resolution is less means in that case we are using less number of bits in each and every pixel, then resolution is decreased. Depending on our application, I need more resolution of an image means we need to increase the number of bits in each and every pixel. So how we can increase means depending on sampling rate increased, then quantization is also increased. Quantization increased means the number of bits in each pixel is also increased, and that image number of pixels are increased means image quality is also increased. And what is adjacency? So what is height adjacency? What is mean by adjacency? So when we go for image, so this is my center pixel. I am representing with f of x comma y. So f of x comma y. In this f of x comma y, total pixels are, here it is 3 by 3. 3 by 3 means total pixels are 9 pixels. Total 9 pixels. Out of this 9 pixels, here this one is center pixel f of x comma y, and this pixel it has neighbors are 4, 2 vertical and 2 horizontal, and diagonally also it consisting of total 4 neighbors. So here 8 adjacency is nothing but in this we are having total 8 neighbors. So that is nothing but n8 of p. So in that in adjacency, so this is the relationship between pixels, it is n4 of p, and in adjacency 2 pixels, if we find the adjacency, if we are considering one problem, here it is, consider one problem here. So this is p, this is p, this is q. This is so from point P to Q. So how to find the adjacent pixels means, in this how to reach from source to destination, in 8 means we can choose this path and this path also. So we need to travel from source to destination. We can choose in neighboring top side, left side, top, right, left, bottom, and diagonal form also. We can choose path to reach from pixel P and pixel P to Q. So two pixels P and Q with values from V are 8 adjacent if Q is in the set of N8 of P, N8 of P. And next one is, what are the steps involved in DIP and digital image processing? So first case, what are the steps involved here? It is image acquisition. First one image. Second one is image transforms. And third one is image enhancement. Next restoration. Next color image model. Next segmentation. And compression. These are the basic blocks involved in our image processing. So here first one is image acquisition and image transformation and image enhancement, segmentation, representation and description, and recognition and interpretation. So these are the basic steps involved in our digital image processing. So first one, image acquisition, image transforms, enhancement, restoration, color image model, and segmentation and compression, and recognize the image and representation. And what is sampling? Sampling is nothing but converts the continuous signal into discrete level. So here Fs is greater than or equals to 2 Fm. Fs greater than or equals to 2 Fm. At that time it converts the continuous signal into discrete form. So this is our continuous signal x and y axis. So when we are applying the sampling, it converts into discrete amplitude levels. So here this is for after sampling. We are applying the sampling technique in this image. We are getting, this is the output. Here it is. Sampling is the process of converting continuous time signal into discrete time signal. And what is quantization? Quantization is nothing but converts the continuous signal x and y axis. So it converts discrete amplitude levels, and this discrete amplitude levels converts into fixed voltage levels. So this is the output for quantization. This is for sampling output. So this is for input. So what is mean by encoding? So after encoding, after quantization, first for converts the analog image into digital form, first use a sampling, next quantization, next go to the encoding. So in this encoding technique, whatever the fixed voltage level, with the use of encoding, it converted into binary form. So here the encoding is the process converting the data from one form to another form. One form to another means here it is fixed voltage level. These voltage levels are either 1 volt, 2 volts and 3, 4 like this. So with the use of encoder, it converts into one form to another means it converted into binary form. Here it is 0. 1 means 0, 0, 1 if it is 3-bit representation. If it is 2-bit representation, 0, 1. If it is 4-bit representation, 0, 0, 0, 1. So for 2 means 0, 1, 0. For 3 means 0, 1, 1. For 4 means 1, 1, 0, 0. This is for 3-bit representation. And 2-bit representation, 1 for 0, 1, 2, 1, 0, 3, 1, 1. So So here 0 to 3 in 3-bit representation we are representing from 0 to 3 only. And what is mean by coordinates? So in this coordinate system we are having 2D and 3D system. So we are representing in coordinate system amplitude and time period in x and y coordinates in amplitude or in time period in both. So in this 2D we are representing in x and y axis, and in 3D we are representing x, y and z directions. What is amplitude? So here amplitude is a set of points or 2D or 3D space. So each point at every we are representing with x comma y is called amplitude or intensity of an image. So we are representing here x, y. Here amplitude levels are, this is my signal. So here this is amplitude level. Here the maximum amplitude level, from here it is 0 point. For example, here it is 2 volts. So this is the representation of the amplitude. So amplitude we are representing in y direction, and time period we are representing with x direction. So here we are representing time period in y direction, we are representing amplitude of an image. So depending on that image, here we are representing the intensity of an image. So amplitude or also it is a intensity of an image. So define adjacency. So what is mean by adjacency? In that adjacency, whose pixel values are same properties. Suppose in that we are having neighboring pixels, the gray levels are satisfied with some specific criterion of similarity is called adjacency. So two pixels are connected. If they are having same gray level or both are in adjacent pixels, then we are joining two pixels. So adjacency is nothing but in that image we are having number of pixels out of for example 1024 pixels. Out of the 1024 pixels whose pixel values are some properties same gray level and those pixels are adjacent pixels, then we are joining pixels. So with the use of adjacency only we can find the boundary path and connectivity distance and region splitting and region merging. So with the use of adjacency pixels, if adjacency pixels connected together means maybe those two pixels are same gray level. So two pixels are connected. If they are neighbors, their gray levels are satisfy the specific criteria of similarity is called adjacency. And next one, what is intensity value of a pixel? So what is mean by intensity or gray level in both are some pixels are represented in the black color. So that pixel value is representing with 0. Some pixel values are some gray level. We are representing with some other gray level value. Some are bright. So we are representing a 2 maximum gray level value. So intensity value of a pixel means entire image, some portion are more bright, some portion of an image is dark. So that is representing that portions we are representing in the form of intensity level. So here a pixel is a small block that represents the amount of gray intensity to be displayed for the particular portion of the image. What is the difference between sampling and quantization? Sampling means it converts the discrete and continuous signal into in discrete form. Quantization means it gives the fixed output voltages. Here, sampling determines the spatial resolution of the digitized images, and quantization is nothing but it determines the number of gray levels in the digitized image. So here sampling means number of samples are increased. Number of samples are increased means it gives the spatial resolution. It gives the maximum output. The image quality is very clear. If number of samples are increased, then number of steps is also increased. Number of quantization levels also increased. Number of quantization levels increased means number of bits and number of pixels in each image is also increased. So if you are increasing number of samples, number of quantization levels, then we can increase the resolution of an image. So here sampling is nothing but it determines the spatial resolution of the digitized images. Quantization is determines the number of gray levels in the digitized images. And what is mean by pixel connectivity? So in this pixel connectivity, two-dimensional and three-dimensional. Here the pixel connectivity, here also same thing, whose pixel values are same, we are connecting or joining those pixels here. Pixel connectivity is the way in which pixel in two-dimensional or three-dimensional images related to the neighbors. And what is scanner? Scanner is a device that captures the image from photographic points, posters, magazines pages, and similar sources for computer editing and display. And M adjacency. So M adjacency is a combination of 4 adjacency and 8 adjacency. In this M adjacency, one condition is there: N4 of P intersect with N4 of Q. Here it is null condition. At that time, we need to choose that path. So that is the difference between when we go for 4 adjacency. With the use of 4 adjacency, we can choose the adjacent pixels are top, bottom, right, left. But in 8 adjacency, we can choose either top, bottom, right, left, and diagonal form also. But in M adjacency, when we go for some problems, here we need to travel from one place to one. Need to travel. We can travel from point P to point Q. We need to choose any one path. But with the use of M adjacency, we will get a multiple paths. So overcome this conflict, we can go for M adjacency. So image geometry. Here, image geometry shape which appears after a transformation has been applied to the pre-image. And define acquisition is a retrieving an image from some source. So adjacency. Here, adjacent. What is 4 adjacency means? In this, here it is f of x comma y in coordinate systems. Here it is x plus 1 comma y. Here it is x comma y. Here plus minus minus x comma y plus 1, and this side x minus 1 comma y. Here x comma y minus 1 in diagonal form. In diagonal form, here x plus 1 comma y plus 1. Here x minus 1 comma y plus 1, and here x minus 1 comma y minus 1. Here x plus 1 comma y minus 1. So in this 4 adjacency means we need to consider only 4, x comma y plus 1 and x plus 1 comma y, x minus 1 comma y, x comma y minus 1. This is for N4 of P. What about N D of P? N D of P in diagonal form, x minus 1 comma y plus 1, x plus 1 comma y plus 1, and x plus 1 comma y minus 1, and x minus 1 comma y minus 1. So this is for N D of P. So when we go for 8 adjacency, combining of these two, add these two, it is nothing but N8 of P. It is nothing but N8 of P. And define digital image. So digital image can be defined by a two-dimensional array, specific arranged in a rows and columns. Define brightness. So brightness is nothing but refers to the overall lightness or darkness of an image. So up to here, definitions and terminologies of a module 1 is completed. So in that basic topics are image acquisition and relationship between pixels and digital camera, grayscale, sampling and quantization. So these are the topics involved in our image processing, and definitions are also completed based on these topics. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.